All right, Unit 1, Day 3, kind of the third day. Third worksheet anyway. Graphical analysis. A lot of what we're going to do today you did in Algebra 2, but we may use some different names for it, and we may put it together in a little bit different way. So if your Algebra 2 is fine, you'll be fine today. If your Algebra 2 is a little shaky, then today might be tricky. Find out where we stand here. Zeros, roots, x-intercepts. The good news is those are all the same thing. We just need to make sure we know that there's different words that mean the same thing. So this is especially, well, I won't say especially during calculus, but it's pre-cal as well. We'll use different words. It's kind of just a vocab test. So I can say find the zeros of this function, find the roots of this function, find the x-intercepts of this function. That's all the same thing. So you just have to know the vocabulary. So let's find the zeros of f of x equals x squared minus 5x minus 6. Complete the square if you want to. I'm going to pass on that. So to find the zeros or the roots or the x-intercepts, they're all the same thing. We'll set y equal to 0. And if y is 0, that makes an x-intercept. Calling it a 0 is where we get the name zeros from. And roots, not sure where the name roots come from, but it's all the same stuff. So let's set y equal to 0. That's a quadratic. So yes, there are multiple ways to solve a quadratic, including complete the square. You're welcome to knock yourself out with that. Or quadratic formula. Or, best of all, factoring. And I picked one that is commonly missed because people think that 3 times 2 is 6. Well, 3 times 2 is 6. But this is not 3 and 2. Because you can't make the signs work out with 3 and 2. So what factors will I use? 6 and 1. But this one messes people up because of the 3, 2, 6, 1. They both make 5. Minus 6 plus 1. And then I'll show the step that most of you won't show, which is fine. Set each factor equal to 0. That's the step that you always skip, and you should skip it most times. So x equals 6 and x equals negative 1. And let's write these as points. So x is 6 and y is 0. That's a little bit more specific. So the zeros are where it crosses the x-axis. So it crosses at 6, 0 and at negative 1, 0. So a little bit of vocabulary, a little bit of factoring. Let's find the x-intercepts. It's the same thing. We're just working on calling it different things. H of x equals x cubed minus 5x squared over 4. So this one's a little bit harder. Set it equal to 0. Thoughts? There's a couple different ways to think about this one. I can't move the 4 to the top. I don't like the 4 there, so I am glad you're looking at the 4. Okay, one thing we could do is multiply both sides by 4, which would just get rid of it, right? But that's good news, and we don't have to worry about it anymore. So you can multiply both sides by 4. The other thing you can kind of think about is if a fraction is going to equal 0, the only way for a fraction to be equal 0 is if the top is 0. So you end up at the same spot. You can multiply both sides by 4, or you can just say, you know what, the only way this thing is 0 is if the top is 0. So you land at the same spot. Two kind of different ways of thinking about it, equally okay. This one's factoring as well, but it's a little bit different factoring. How am I going to factor that? Yeah, take out an x squared. GCF is like the easiest kind of factoring, but because we don't use it all the time, people forget about it and they try to do something difficult with this when just taking out the x squared was the right way to go. Let's set both factors equal to 0. This is the step that you skip, but if you skip it for this problem, you might miss something. So x equals 5, that's the easy one. What about if x squared equals 0? What's that lead to? 0. So 0, 0, and 5, 0 are my x-intercepts. For the third problem, let's find the roots. It's just the same thing. Find the roots of g of x equals square root of 3x minus 4. So again, we're combining some algebra with some vocabulary. Zeros, x-intercepts, roots all mean the same thing. Set is equal to 0. Now we've got our algebra to worry about. What do you want to do first on this one? Add 4 to both sides. Square both sides to get rid of the square root. Four squared is 16. What about the square root of 3x squared? 3x, right? That was the whole point of squaring it, was to get rid of the square root. They cancel each other out, and we've got 3x. What about that plus or minus thing? Sometimes we have to worry about putting a plus or minus on there. Do we need to do that in this case? No. Well, so what am I thinking about? When do we put the plus or minus on? When you what? When you put the square roots on, then you put a plus or minus on there. So if you square both sides, you're fine. You don't have to worry about it. If you square root both sides, that's when you do the plus or minus. So x equals 16 thirds, which means the point is 16 thirds, comma 0. Roman numeral 2 of 4, if you're keeping up. Intersection. So this is another like vocab word that's going to lead to some algebra. Let's find the intersection of f of x equals 2x squared minus 16 and g of x equals x squared plus 5x plus 20. So, intersection. How are we going to find where they intersect? Okay, we think about the graph. So we'd be looking where the points are the same.
Can't you just
on the graph.
find where each one of the points are the same?
So I do want to find where the points are the same. How can I do that algebraically, not with a calculator, at least not yet? But what do I do first? I mean, I could factor them separately, but that doesn't really help.
Set them equal to each other.
set them equal to each other. That's kind of where we're headed with intersection. Because I want to know where they're the same, so I'll set them equal to each other. So 2x squared minus 16 equals x squared plus 5x plus 20. It's a quadratic, so I need to move everybody to one side and hope that it factors. So x squared minus 5x minus 36 equals 0. Let's see. Here's where we find out if I wrote a good problem or not. Does that factor? Multiply to 36, add to 5.
I think so.
Somebody said it, I think. 9 and 4. With a negative 9 and a positive 4. X equals 9, x equals negative 4. I'm writing smaller since I'm at the end of the page. This isn't exactly the type of answer I want. Maybe I should have been more specific because I want the points of intersection. Those aren't points yet. I've got the x, I need the y. So I need to plug it back in. Which one do I plug it back into? The f or the g?
It doesn't matter if it's F
It's kind of a trick question. Either one, because they're equal to each other. That was how this problem started. So I can plug it into either one, whichever one you think is simpler. Or if you really wanted to be careful, you could plug it into both and make sure you got the same thing. I think F looks easier than G, so I'm going to plug it into F. F of 9. 2 times 9 squared minus 16. So do I do 81 times 2 or do I do 18 squared?
81 times 2.
Right. I overheard Coach Stringer just now say PIMDAS, exponents before multiplication. So 2 times 81, 162, minus 16. This is why you could have a calculator. 146. So the point then is 9, 146. So graphing it, I mean, yeah, exactly. If you'd have known where to look, they intersect at 9, 146, but yeah, it's a big piece of paper. But even graphing it on the calculator, you would have had your window. You would have to fix your windows to get there. Let's find the other one, f of negative 4. This one should be easier. Let's see, 2 times 16, 32 minus 16 is 16. So negative 4, 16. So again, this is algebra review, but it's been a while. I want to make sure we know the words and the processes for finding some of this stuff. Roman numeral 3. Increasing, decreasing, and constant. And these are intervals. I don't know that I really need to write this down, but we read a graph like we read a book from left to right. So some people get confused, and we'll see a picture in a minute that is intentionally confusing, but you read the graph like you read a book, from working from left to right. Rarely do I ask you to copy down a graph exactly like I have it, but this is one of those
I'm looking
times.
at your bell schedule. I'm in the.
So let's put a point at -2, -3. And a point at 1, 2. And then make your graph look something like that. And we want to give the interval, so interval notation, of where it's increasing, where it's decreasing, and where it's constant. And there's kind of two ways to do this. You can do it looking at this first, so go find the increasing interval first, and then the decreasing, and then the constant. Or you can look at your graph and read it left to right. I think it's more helpful to look at the graph and read it left to right. So as we go from left to right, what's happening on this branch right here? Is that increasing, decreasing, or constant?
Increasing.
Good. And that was where I tried to trick you, but you were not fooled. Right? Some people see that arrow up, and they're like, well, look, it's going up over there. Like, well, I mean, yes, it is, but as we move from left to right, it's decreasing. So it's decreasing. Well, I want x. I have to use x values. So where is it decreasing from? Where does it start decreasing?
Negative infinity.
Yeah, -infinity up to -2. And at -2 it changes, so we don't want to say it's decreasing at -2 because it's not really decreasing at -2. Let's not include -2 in our interval. Well, if you got that one, you'll get the rest of them, I think. How about this interval? What's going on there? Increasing. Now here's the other place that people mess up. When we give intervals, it's always x values in our intervals. And the trick is increasing and decreasing, you're looking at y values, right? Like it goes from -3 to 2, so it's increasing. But when we write the increasing interval, we need to write an x interval. So the thing that people miss is they'll tell me that it increases from -3 to 2. I'm like, well, not wrong, but that's not what I'm asking. I'm asking for x values. So what are the x values for that increasing interval? -2 to 1. So yes, you're looking at the y values to see where it's going up and going down, but when you tell me what the intervals are, you got to use x intervals, x values. Running out of colors up here. Well, that's an easy one. That one's constant. That starts at 1 and goes to infinity. And obviously we could come up with a whole manner of graphs, and you might have more than one increasing interval, so you'd have to put the u there and then put all the other ones. But this was a simple one. Increasing, decreasing, constant. Right. Part B, with the calculator, let's find the minimum of this graph. And you'll see why we need a calculator in a minute, because I have no idea what that looks like. Y equals -x times the square root of 6 minus x. Now, you know what a minimum is. We don't know that we've used that word in a math sense before. So let's graph it. And I probably need to see a better window than that. Let's go to the standard window, maybe that'll help. All right, so where is the minimum? Can you describe in words where the minimum is? At the bottom, that's one way to say it. I don't know where it is, but the minimum would be at the bottom of a valley. It'd be a point that's lower than his neighbors or its neighbors. So if the graph looked like that, there would be two relative minimums or local minimums. Those are kind of calculus words. So like locally, they are at the bottom. Relative to its neighbors, they're at the bottom. When we get to calculus, we'll talk about absolute mins and maxes. Which one of those do you think is the absolute minimum? B, because it's the absolute lowest.
My calculator keeps on every time I try and click graph, it just says window range, but it's an error.
Go to Zoom and pick Zoom Standard. That might fix it. Zoom and then Zoom Standard. So minimums are the bottoms, maximums are the tops. Let's go back to this particular graph. Negative x square root of 6 minus x. We can tell by looking like the minimum's there. And there's a couple ways to find it. Some people mistakenly use trace. Like, well, if I trace, I can get over there like close to it. Like it's probably about there. But there's a better way. Your calculator can find what it is. So go to second calc. And that's really all you have to remember. There's a teacher that's teaching pre-calc for the first time this year, and we were talking through how to find this. And she's like, okay, how do I find it again? And me and Miss Murray were like, well, you use second calc, and after that, I don't know, it'll walk you through it from there. So second calc, it's like, oh, we're looking for a minimum, so I should probably pick the button that says minimum. And then it walks you through. So left bound means get to the left of the minimum. So get to the left of it somewhere. Doesn't really matter where. The tighter your window, the quicker your calculator does it, but it happens in milliseconds, so it doesn't really matter a whole lot. Press enter. Right bound, so get to the right of the minimum, so somewhere on the right hand side. And press enter. And then it asks for a guess. And as long as your guess is in between your two arrows, you'll be fine. So some people will just hit enter again and say that that's their guess. It's not a very good guess, but who cares? The calculator is the one doing all the work. So you can hit enter, or you can try to help your calculator out and say, it looks like that's the lowest spot right there. And if you pick a low spot, it'll get there quicker. But again, it's like 0.1 seconds versus 0.11 seconds. So you're not really saving any time here. Oh, this is a good example. Because the calculator says my minimum's at X value of 3.9999988.
Mine says 4.066 or 4.0000006.
If it says it should say 4. If it says 4.0, there should be a whole bunch of zeros. So it doesn't quite get there exactly, but I'm pretty sure that it's trying to tell me that it's 4. Now the Y value, that one's not as clear. So I guess we'll just round to 3 decimal places and 657. So there's the minimum of that graph that the calculator found. When you get to calculus, you'll figure out how to find it differently, but we're not there yet. Not by a long way. So the big thing is don't use trace, because that won't be accurate. I mean, it'll get you in the neighborhood, but don't use trace. Use second calc minimum or maximum if it's a maximum problem, and then just follow the prompts. Like, do what it says to do, and you'll get there. All right, last thing, and that is average rate of change. Average rate of change. Well, this is more of a vocab word than a math. It's a new vocab word more than a new math process, because the average rate of change is the same thing as the slope formula. So it's like you already know how to do average rate of change. You may not have known that that's what it was called. So let's find the average rate of change, an abbreviation we like to use in calculus, because in calculus we'll also have an instantaneous rate of change, and so we keep them separate. Average rate of change for y equals x squared minus 3x plus 7 from x equals 1 to x equals 4. So again, it's just a fancy way to say slope. So I need to find y of 4 and y of 1. So I need to plug in 4 and plug in 1. That'll get me the y values. So 4 squared minus 3 times 4 plus 7. And again, you'll have a calculator for this, so if you don't want to mess up something simple. So that's 11. Y of 1 squared minus 3 plus 7. So negative 2 plus 7 is 5. And you might remember from slope, like the order you put them in, it doesn't matter as long as it's the same top and bottom. So you can do y4 minus y1 or y1 minus y4 as long as you do the same thing on the top and the bottom. So 11 minus 5 over 4 minus 1. Oh, I picked an easy one that came out to be a nice answer. Not guaranteed to be an integer. You could end up with a fraction there. So its average rate of change, or sort of its average slope between those 2 points, is 2. Let's see if I can show you what that looks like on the graph. So between 1 and 4 on the graph, it has a slope of 2. An average slope. Between 1 and 4, an average slope of 2. And that really matters more in calculus is when we'll use it. So we just introduce it today. All right, today's assignment is worksheet 3. And remember that due on block day is worksheet 1 through 3. So ideally 1 and 2 are already done, or should be close to done. We answered a few questions today. We'll answer questions on worksheet 3 tomorrow, and then you can clean those up if you need to. And then on block day you'll turn in 1 through 3. So you should have plenty of time to get these 3 finished and ready to go.
I understood it all, besides the whole fraction part you did by the AR.
So everything but average rate of change.
Well, this the part
Down here?
right above
So you're okay with this. That's just good old... No, not okay with that.
that. Well, that's where you getting the word.
I got the numbers from... So the formula is just the old Algebra 1 slope formula. The numbers I got are y2 minus y1, or f of 4 minus f of 1. The two y values and the two x values. So 11 goes in for y4 and 5 goes in for y1. Those are the two y values. If I don't know, this may be overkill, but you could make a table of values and kind of do it from there, if that helps. Because then you would just be doing the slope with those 2 points. Change in y over change in x.